Motion diagrams and graphs in Graphic Organizer 7E's model. Elicit. Can you recall concepts about kinematics? It simply deals with the description of motion. Speed, meaning how fast the object moves. Velocity, speed with given direction. Acceleration, the rate of change in velocity. Brilliant! Engage. The picture shows different rates of motion. This is the reason why they are not abreast with each other. Can we represent the respective motion using graphs? Of course, but let us first tackle motion diagrams. Explore. The motion diagrams show yellow arrows, net force acting on the moving body, and velocities, the green arrows. The yellow arrows are equal in lengths from initial to final, which means a constant net force. Then why the green ones are still increasing? The second law states that constant net force would cause constant acceleration. Constant acceleration means constant increase of magnitude in velocity. So the above picture gives a constant increase of 1 meter per second, while 2 meter per second constant increase as shown in the diagram below. Explore. The motion diagram at this time have increasing or decreasing net force. Both increasing and decreasing net force cause increasing velocities. Why? The above yellow arrow shows an increased net force. That's understood that it would naturally increase velocities. Yes, because increasing net force would result to an increasing change in velocity. The acceleration is not anymore constant, but increasing in magnitude. But what about the lower picture? The net force is decreasing, but velocity is still continually increasing. Remember that the net force would always result to change in velocity. In the picture below, there is still an increase in velocity, but with decreasing change in magnitude. Explore. The object in this case is directed to the left, but the net force is to the right. Is this possible? What is the direction of acceleration now and its effect to the motion of the body? In such case, the motion will decrease its magnitude constantly for constant net force and increasingly for increasing net force. While net force and acceleration will always be in the same direction, on the other hand, the acceleration need not always be in the same direction with body's motion. Explore. Let's go back to our motion diagrams. Can you describe the motion using graphical representations? You mean the position time, velocity time, and acceleration time graphs? That would be challenging. Let's try first force time graph of the motion diagram as shown. You have constant net force and strong net force. What color in our FT graph best describes the diagram? I think the red horizontal line, because there is no decrease or increase in net force. That's correct. Our net force is constant. Explain. How about this diagram? What FT graph that best describes the motion? The green? Try to look closely. All of the colors represent increasing net force, except the red line. Yellow curves shows the net force increases with increasing magnitude of increase. Green has constant increase, while blue increases with increasing magnitude of interval. So it's blue. The increase is increasing. That's correct. Probably. How about this force-time graph of the motion diagram as shown? Decreasing net force. What color in our FT graph best describes the diagram? I think the yellow line. Nope. Our net force is decreasing. Yellow has increasing net force. Only the change decreases. What does it mean? All the lines except red shows increasing acceleration. But our motion describe or our diagram shows decreasing net force. So the yellow line would cause decreasing acceleration. The green line gives constant acceleration, while the blue line will give increasing acceleration. Consequently, in all cases except red or the red line, the body speeds up. So more probably the orange curve. Exactly. Explain. Sure, you can identify now or what particular line the above diagrams represent. Surely, the decreasing net force would be represented by the black curving down. On the lower picture, the net force opposing the motion could still be represented by blue curve, since it represents opposing and increasing net force, resulted to increasing decrease of speed of the body. Explore. Can you describe the motion represented by the curve in our distance-time graph? Oh, this is hard. Explain. As shown in the distance covered per unit time, A gives an increasing slope, increasing velocity. B, constant slope with constant velocity. C, decreasing slope, meaning decreasing velocity. D, zero slope, so zero velocity, it stops moving. E, negative slope, velocity is increasing in its speed, but in opposite direction. F, flattening curve, but still negative curve, negative velocity with decreasing speed. G, negative constant slope, meaning constant velocity, but negative. H, similar to F. I, similar to D. Note that starting from A to D, the objects move backwards, negative. Explore. What happens if it becomes velocity time graph like this? In this case, the description of motion would be different. Explain. A, increasing slope with increasing acceleration. B, constant slope with constant acceleration. C, decreasing slope, meaning decreasing acceleration. D, zero slope, constant velocity, meaning zero acceleration. E, negative slope, negative acceleration but still increasing in magnitude in terms of velocity. F, flattening the curve but still negative curve, meaning negative acceleration with decreasing magnitude of change. G, negative constant slope, meaning constant acceleration but negative. H, similar to F. I, similar to D. Note that starting from A to X, the object moves forward, but from X to I, the object moves backwards. So at point X, the object momentarily stops and reverses its direction. Explore. What about the acceleration time graph as shown below? Can you describe the motion of the object? Let's try doing it. Explain. A, positive constant acceleration. The body speeds up constantly. B, decreasing acceleration, but still the body increases its velocity. C, negative acceleration. The body slows down in this case. Meaning in lines C, D, and E, the accelerations are negative, which means the initial velocity is greater than final velocity. In this case, the net force is opposite to its motion. That's correct. D, acceleration is constant but negative. The object slows down constantly with equal interval of decrease in velocity. E, the body still slowing down but with decreasing magnitude of decrease. F, the acceleration is zero. The body continues to move at constant rate. Evaluate. Can you give a graphical representation of this motion diagram? I think the graphs would look like this. Distance time with curving up, meaning increasing in distance. Velocity time, constant increase in velocity. For acceleration time, this is constant acceleration. Net force, constant net force, of course. That's great. Evaluate. How about this one? Constant motion. Can you give graphical representation of this motion diagram? I think the graphs would look like this. Distance time, we have constant increase in distance. Velocity time, you have positive, constant velocity. Acceleration time, you have zero, of course, zero acceleration. The same with net force, zero net force. Excellent. Extend. What would be the motion diagrams and graphical representations for object moving to the right, then slowing down constantly, and then goes back to the opposite direction and speeds up constantly, then to a constant velocity? That serves as your assignment. No, I want you to help me, please. Okay. Going to the right, the object is being acted by opposing constant net force, which, of course, decelerates its motion constantly until it stops. Below, the same constant force that accelerates the object constantly at first, then no more net force acting, so it keeps moving constantly. Wow, that's Newton's second law, then first law. The graphical representations would look like this. For force going right, of course, opposing to its motion, below the zero mark. Then going to the left, the same force that acts constantly. And then to have a constant velocity, net force should be zero. The same graph for acceleration. For distance, going right, this is curving up, then down, decreasing until it stops. Then going back, going to the left, that's curving down, and then moving constant V represented by red straight line. How about velocity? Of course, the velocity going right would look like this, and then going left, of course, a negative direction, and then constant V, straight velocity, straight line, horizontal.